Version 12 relies exclusively on INI files to store settings. It also uses INI files to save data for exporting and importing. To avoid problems with formatting and default characters, when using different regional settings in Windows, version 12 forces all programs to use US-centric settings, as shown in the information on the screen.
Welcome to this tutorial on how to use MPO Canopus to do time series variable star photometry. It will cover producing the data for lightcurve period analysis, but not the analysis itself. A separate tutorial goes through the steps of using the data from this tutorial to find the lightcurve and period of the variable star. You may have an easier time with this tutorial if you view a couple of others beforehand. First is the one on creating batch reference files. Those store the names, RA and DEC of the target or targets, a check star, and the comp stars. That tutorial gives more details on some aspects of batch reference files, while this one presumes at least an understanding of what they are and how they're created. If you have not created the tutorial's user profile, you should do that before going through this exercise. The profile you create is used in other variable star tutorials. You'll find the video on the MPO YouTube channel. And if you haven't already viewed the tutorial on the image form, you should also watch it before going on. It gives an overview of a form that you'll see here and in many other MPO programs that display FITS images. To save time, it's assumed that you're familiar with the image form basics and can concentrate on the steps required to generate the data. These are the general steps that will be shown in this tutorial. Each one needs to be taken in the order given and relies on successfully completing all of those before it. While you may be working with the same sample images that were used for this tutorial, you may not see everything exactly the same and your results may differ slightly. Don't let this get in the way of learning the steps. The goal is to learn and become comfortable with the steps, not to duplicate results exactly. Very similar results will be good enough. Anytime a directory path is mentioned, it will be assumed that the version 12 directory tree is off the root of a drive, for example, C:\\MPO V12. Anytime a path is referenced, it appears as just MPO V12. For example, MPO V12 / and then the rest of the directory or file path. It's also assumed that you did not change any of the V12 subdirectory names and that you downloaded the sample images used in this tutorial.
The first step is to start the program and make sure that the configuration settings are correct for the images and circumstances. Start the MPO launcher and open the Photometry section. Now click on Variable Star and wait for the configuration program to appear. If needed, click on the Config button in the left-hand panel so that the Observer and Equipment tabs is shown. The next 3 slides show the settings for the 9 tabs on the configuration form. Each will be shown for about 7 seconds. You can pause the video or, better yet, download the PDF with tutorial slides from the BDW Publishing website. Please note that these settings are based on those used for images taken at the Center for Solar System Studies, and will not necessarily be correct for your observatory setup. These are the settings for the Observer, General, and MPC tabs. These are the settings for the Catalogs, Charting, and Charting Miscellaneous tabs. These are the settings for the Photometry, Plotting, and Output and URLs tabs. A batch reference file is a simple text file that contains all the necessary information to set the comps, variables, and check star automatically prior to measuring images. This means that you can avoid all the steps of selecting and setting those stars each time you measure the star field supported by the batch reference file. There are two ways to proceed from here. They depend on whether or not you have a batch reference file for the images to be measured. As the great philosopher, Yogi Berra said, when you get to a fork in the road, take it. Whether or not you have a batch reference file, there are certain, required preliminary steps before you take the fork in the road. These are covered in the next few sections of this tutorial.
Reviewing images is not required. If you have confidence that all the images are measurable, that is, no satellites, airplanes, clouds, or bad tracking, you can save the time it takes to review the images. Whether or not you review images, there are some steps common to both methods. Set the review switch to yes or no, depending on if you're reviewing images or not. Load any flat, dark, and/or bias frames that are needed. Set the image sizing so that you can see at least most of each image. Set image scaling to normal or compressed, depending on which is better for the images or your viewing preference. Select the images to be measured. Here are the steps if you are not previewing images. Note that the every X images value is ignored. The images to select will be the images that are measured. When you've selected the images, the label at top right shows the number of images loaded and selected to be the same. Click the Accept button to move to the next tab, where you will specify comp stars, one or more variables, and the check star. You can fast forward the video until you see the Measuring Run Setup section break. In this tutorial, we'll assume that some of the images may not be ideally suited for measuring data. To see which ones are out of favor, large thumbnails of all of the available images are created and displayed on the Review tab. Set the review switch to Yes to create and display selected images. Set scaling to Compressed. This means that all the images loaded from here on will use a grayscale that maximizes seeing faint stars. This is optional. If you prefer normal scaling, you can choose that instead. Set the size scaling to 67 or 75%. The original images are 1024 by 1024 pixels. This setting allows seeing as much of the image as possible. Set the measuring apertures as shown on the screen. The chosen colors are not required, but they do help by having noticeably different colors for variables, comp stars, and those found in the astrometric solution. Set every X images to 1. This means to use every image that is selected in this step. If the number is greater than 1, then a subset of the images is used. For better measurements, a flat frame should be used. Click the Flat button at the bottom of the form to display a File Open dialog. Navigate to the example images for this tutorial and select the image shown on the screen. Remember that MPO-EX is shorthand for long file path that starts under the MPO V12/examples directory. The color of the LED lights next to each of the processing image buttons indicates the status of their processing frame. Click the Folder button at the upper left to open a multi-file selection dialog. Navigate to the example images for 2023 May 12th and select all the images. Note that this example set includes images numbered as a multiple of 5. The original full set had more than 240 images. In general, you want to select all the available usable images, especially the first and last to be measured. The program will do the math to build a subset if every X images is greater than 1. Click the Open button on the dialog. This starts loading the path to each selected image to an internal list. The images themselves are not stored in memory. If you want to stop loading, click the X button, which is enabled only while the images are being loaded. Click the Trash Can button after the images have been loaded if you don't like the set of images, or they're the wrong ones entirely. This clears the form and the internal list so that you can start over. The point of this step is to look for bad images so that they aren't measured. Otherwise, you may get bad data points and you'll have to track down what caused them. You may still have to do this, but it won't be because one image included a low-flying airplane or a satellite going right over the variable star. Double-click on a suspicious image to display a larger version. If the image should not be measured, you can exclude it from the final set of selected images. Click the green check mark at the bottom right of a thumbnail to exclude it from the selected list. The check mark is replaced by a red X. To exclude a contiguous range of images, click on the green check mark of the first image to be excluded, and then Control-Shift-Click on the last images. The green check marks for all images from the first to the last are set to a red X. Click on the red X of an image to restore it to a green check mark. Should the image be the first in a contiguous range of images to be restored, Shift plus click on the last image of the range. The red X buttons revert to a green check mark. To extend a contiguous range of excluded images, Control-Shift-Click on the new last image of the range. Say there is at least one good image beyond the last bad image of a contiguous range. Click on the first image and, if needed, create a new contiguous range of excluded images. As you include or exclude images, note that the label at top right shows a constant number of images loaded, which is the number of images that were selected in the File Open dialog, while the number of selected images changes to reflect the number of green check marks, that is, the images to be accepted for measuring. All the images were all good, so the two numbers are the same in this tutorial. Once you've selected all the images to be measured, click the Accept button to move to the next page, where you'll select comp stars, one or more variables, add a check star.
A measuring run requires a set of comp stars, one or more variables, and a check star. It also needs some other information before the run can start. Check the Cat Only checkbox. This means that only stars from the primary star catalog, a pass in this case, will be used to generate the underlying star chart and the list of candidates for auto-selected comp stars. If the box is not checked, stars from other catalogs can be included, but only if the primary catalog had less than 75 stars. Select a pass from the drop-down list of supported star catalogs. This catalog must have a priority of 1 on the Configuration Catalogs tab. It is chosen over the Atlas catalog because the latter's V magnitudes have higher systematic errors. Set the filter to CV. This means a clear filter was used and the comp star V magnitudes were used to find the variable and check magnitudes. This setting is independent of the mag band of the comp stars. Technically, you could use AB filter with cousins R comp star magnitudes. Doing so is not encouraged. Set the mag band to Johnson V. This ties with the CV filter selection, but generally this setting is independent of the filter. Version 12 distinguishes between the Sloan and Pan-STARRS photometric systems. Both use GRIZ filters and bands, but the 0 points and color dependencies are not the same. The Atlas catalog has Pan-STARRS magnitudes while the A-PASS, CMC15, and UCAC4 catalogs are on the Sloan photometric system. The MPO SC3 catalog is not recommended for photometry. Select VR for CI, the color index. A better choice might be BV, especially if you want to apply transforms for your system while analyzing the data. It is important to remember that only raw data are stored during measuring. Any corrections due to air mass or colors are applied only when doing analysis. For example, this allows changing to a different color index without having to remeasure images or try to back out the original corrections. Select an available camera and telescope. These are for a complete historical record. If there is a known systematic difference among 2 or more cameras, telescopes, or combinations of both, this would be important information. Set SNR to 50. This is the minimum SNR allowed when auto-selecting comp stars. This is a good value for this set of images, but it may be too high or low under different circumstances. Set SAT to 75%. If the first image is at low altitude, then, as it rises, stars will get several tenths of a magnitude brighter. This setting helps avoid selecting comp stars that will reach saturation when the field reaches maximum altitude. You may find that a lower setting, such as 50 to 60% may be better. Set minute to 3. This is the minimum number of comps allowed to accept the set and move to the next stage. It can be more, but it should be at least 2. Set 0 flag to no. A non-zero flag indicates that a star in the Sextractor star file that's saturated, blended with one or more other stars, or there is an image defect of some sort. By setting the switch to no, this allows any star, regardless of the flag value, to be considered for astrometry and comp stars. Yes is usually the better choice, so that stars that have a non-zero flag in the Sextractor star file will not be considered. This setting was prompted by trying to work a variable with a large bright globular cluster in one corner. Without excluding non-zero flag stars, the program tried to get a match using stars in the cluster. Set sigma to 1.5. The value is part of the settings for the Sextractor program and helps define a lower level for data values, that is this many sigmas above the average noise level. Usually, the default value is between 1 and 2. However, this may prevent very faint stars from being extracted, one of which might be an intended target variable. As the sigma value decreases, more stars are extracted. However, this also generates a growing number of false positives, those small clumps of noise that really aren't a faint star. The setting has an effect on auto-match times because the program looks at every extracted star to see if it's in one of the star catalogs being used. More stars means more comparisons, and so longer times until that step is done. Set the mode switch to new. This means that a new session is to be created and that comps from a previous session will not be used. If the switch is set to edit, then the comps from a previous session will be used and you will have to choose which session has the comp stars. Set the source switch to auto. This means that the program will auto-select up to 15 potential comp stars in a list that can be edited as needed. Only the comps are selected automatically. You must still tell the program which stars in the field are variable star and pick a check star. Once you've defined the comps, targets and check star, you can save the information to a batch reference file, which makes creating a new session much easier. If the switch is set to batch, then you must use a batch reference file to locate the comps, targets and check star. This can be one that already exists, or one that you create and save on the fly. Check the solar checkbox. This limits the potential comp stars to those of near solar color, which helps reduce color difference errors, but only if the target is not excessively red or blue. Also, so-called average solar color stars tend not to be variable, but that's not guaranteed.
Here's where you take the fork in the road. If you have a batch reference file in hand, then you can skip ahead to the Selected Comp Stars Batch chapter. For this tutorial, it's assumed that you do not have a batch reference file and need to take the steps that eventually lead to creating one. Click the Load button to get started. This automatically loads and auto-matches the first image in the set of selected images. After a few seconds, a message appears saying if the image was auto-matched or not. If successful, click the OK button. Note that this step is required even if using comps from a previous session, so that the program can locate those comps on the first image. Click the Comps button. The program scans the stars extracted from the image for those meeting the requirements from the measuring run setup. When done scanning, the auto-selected comps are displayed on the image. They are assigned a number and, since we're favoring solar color stars, they're surrounded by an orange circle. The comps are also displayed in the list on the right side of the form. Do not accept the list without first reviewing it and, if necessary, editing the list until you have a good set of comp stars. The first check is to see if the selected Comp 1 star isn't too bright or has a close companion. Review the other comp stars for the same reasons. Compare the selected comp stars against known variables. On the right is the finder chart generated by the AAVSO website when trying to create a batch reference file. Locate AF and V1208 Herculeum on the image. The other two variables in the chart were rejected after consulting with the Variable Star Index website. In the comps list generated for this tutorial, comp 1 is too close to the edge of the image. Since the maximum of 15 comp stars has been reached, let's work with that list as is for the moment. First, look for a good replacement among the comps already selected. A rule of thumb is that the comp star should be within 2 magnitudes or so of the average magnitude of the variable. At the very least, try to make comp 1 fit that rule. Click on the soon-to-be comp 1 in the list. Note that it alone is now within a circle on the image. Click the key button under the top list. This swaps places of the star and the original comp 1 in the list, with the now retired comp 1 taking on the replacement star's number. Since the original comp 1 wasn't a good choice at all, it should be removed from the list. Click on it in the list and then click the minus button. This deletes the star from the list, and it is no longer among the chosen stars on the image, although it is still surrounded by an orange circle. What if there are 15 comp stars in the list, and you don't like any of the others in the list for comp 1? However, you do like one that was surrounded by an orange circle. Click on comp 1 in the list, and then click the minus button. This removes the star from the list and image, but it may also raise a warning about there not being a primary comp star. Dismiss that warning. Now this list has less than 15 stars and you can proceed. Click on the circled star in the image. It appears by itself on the image. Click the plus button under the top list on the right. This adds the star to the list but as the next available number, in this case 15. Click on the new star in the list and then click the key button. This swaps the new star with the previous comp 1. Note that if you click on any star in the list and then click the key button, it automatically swaps places with the then comp 1. The selected star is now comp 1 and has an asterisk at the left side of its line in the list. Continue editing the list by deleting and adding stars until, if possible, you have the maximum of 15 stars. Do not click the Accept button just yet. You haven't set the variables in check star.
Click on the Vase tab on the right. Click on AF Herculeum in the image. Click the plus button on the Vase tab. This adds the star to the list. Note that it does not appear as AFR in the list, but with a catalog number of some sort. The order of the next few steps is important. Click on the star in the list. The star is now surrounded by a sky blue circle, and is the only one with a circle. Enter AFR in the edit field just below the top list. Click the pencil button between the two lists so that the new name appears both in the list and on the image. Do not click the pencil button before entering the correct name in the edit field. The pencil button is like saying, use what's there, not I want to make some edits. Note the Nemesis button below the vase list. What does it do? The name Nemesis comes from a program written by Liu Cook that is found on the AAVSO website. A Nemesis star is one that is too close to the variable to be safely excluded by a carefully chosen set of measuring apertures. The solution is to measure the combined light of the variable and Nemesis star, and then subtract the Nemesis star's contribution. Of course, you must know the catalog magnitude of the Nemesis star in the same mag band being used for the comp stars. Assume that a 17.0 star is sitting next to the variable. Click on the variable in the list. Click the Nemesis button to display a form where you set the Nemesis star magnitude and the apertures used to measure both stars at the same time. Enter a set of apertures that will safely contain the target and companion. In other words, an inner aperture that assures that the faint wings of both stars are well within the aperture. The apertures do not need to be circular. In fact, an elliptical aperture set with a 0 or non-zero rotation angle may be better, because it can exclude unwanted sky data that using a circular aperture set would include. The information for the variable star that is in the lower read-only control now contains information about the Nemesis star. Do not click the pencil button. This will clear the Nemesis information. Click the Refresh button to refresh the display with all the selected comps, variables and check star. Do not click the Accept button at this time. You have more work to do. Click on V12 on the image. Click the Add button on the Vars tab to add the star to the variables list. It may have a catalog number, or a name, or the word selected followed by a number. The latter is a star that was extracted from the image, but could not be found in any of the catalogs, and/or did not meet the restrictions for comp stars in the measuring run setup. Click on V12 in the list. Enter V12 in the Edit field and then click the pencil button. The star appears with the proper name in the list and on the image. If necessary and when one is required, each variable star can have its own Nemesis star magnitude and set of apertures that are independent of the settings for any other variable. Each variable's Nemesis settings are its own. You are getting close. But don't touch that Accept button just yet. One and only one check star must be defined before images can be measured. A check star is a control target that must not be variable, and preferably similar in magnitude to the primary variable star. The check star is used to confirm that none of the comp stars is variable. Ideally, if the check star magnitude is steady when compared to the average of the comp stars, the comps are okay. If the check star magnitude varies, then one or more of the comp stars may be variable. To confirm that the check star is not itself variable, plot its raw magnitudes. There may be a trend that follows changing air mass, but if the check varies beyond that, it may not be such a good check star. If you don't know of one in advance, click on what appears to be a good check star. It should be surrounded by an orange circle, which means that it's near solar color and meets the other comp star requirements in the measuring run setup. Do not change the name of the check star. Click the Transfer button just above the information box on the Check tab. This transfers the catalog magnitude and RA and declination of the star to the Notes field at the top of the form. This is included in AAVSO reports so that they can record which star you used. Enter X35684AO, not 0 in the chart field. This came from the Finder chart generated by the AAVSO website for the AFHA field. Enter XXX in the ARBS field. When you get an observer code of your own from the AAVSO, you would enter it here. Review again the comps, variables and check star. Make sure the correct names are set for the variables, that the check star information has been transferred to the Notes field and the chart and ARBS fields have valid entries. Keep your mouse pointer away from the Accept button. You want to save what you've done so that you don't have to do it all over again for the next measuring run for the same star.
Return to the Comps tab. Click the To Be RF button to display a File Save dialog. Select the path and enter a file name. The file extension is always forced to be TXT, a text file. The installation program creates an AAVSO directory off the root of the V12 installation. This, or a subdirectory of it, might be a good place to save the file. A good name might be to include the primary variable name and BRF before the extension, indicating that it is a batch reference file. This is not required. Click the Save button on the dialog. In this case, the assumption is that you have a batch reference file, either version 12 or a legacy version 10 for the field to be measured. It could be one created before or even the one you just created by following the steps in the previous sections. Even with a batch reference file at hand, you must still select and accept a set of images to be measured on the Review tab. It's optional if you actually review the images or not. Load image 1 to get an auto match. Set the preliminary controls such as the filter, mag band, equipment, etc. Set the source switch to batch. Click the Comps button. This displays the batch reference file editor. Click the Load button on the editor if you already have a batch reference file for the images to be measured. Locate and open that file in the File Open dialog. If you're loading a legacy version 10, confirm all the entries and then click the Save button on the editor to create a version 12 file. You should use this new file every time you measure the field. All potential comps are auto-selected. Each item in the VRF is loaded into an internal list. This takes only a second or two. When done, the comps, variables, and check are shown on the image and in the list. Click the Save button on the editor if any changes were made or if the file you located was a legacy version 10 file. Click the OK button on the editor to close it. Confirm everything, comps, variables, check before you proceed.
Finally, now you can click the Accept button. This starts the process of creating a session by transferring all the information about equipment, filters, magband, and more, along with that for the comps, variables, and check star. This can take a few seconds, so be patient. After the session is created, the program switches to the Sessions page. If not already there, scroll to the bottom of the table, or use the Table Navigator controls. Go to the End button, where you'll see that 2 sessions have been created, one each for AF and V12 08 Herculeum. If you need to change anything in a session, make sure it is highlighted and then click the Edit button under the Details table on the right side of the form. Be very careful when editing, otherwise, you could enter invalid data. If there is no telescope and/or camera, click the button to the right of the scope field to display the equipment lists editor. When done with the changes, click the Save button. Click the Cancel button if you want to exit editing and not save any changes. If you make edits on one of the sessions created at the same time, you need to make those same changes on every other session. There is no Accept button, so make sure that the primary session is highlighted and then click on the Measure tab.
Set TO to 30. This is the number of seconds that the program allows for an auto match to succeed or fail. If the auto match is not finished after TO seconds, the program stops the auto match and a failed message appears. Set delay to 0. This is the number of seconds to pause after measuring an image before automatically loading the next one, or to be ready for you to press the Enter button on the keyboard to continue. A value of 0 is actually about 1/6 of a second, so that the program can process pending messages and not get stuck in what's called a tight loop. Set Beep to Off if you don't want to hear the computer beep after each image is measured. If set to On, the beep sounds. This is handy should you step away from the computer while measuring, by letting you know that the program is proceeding through the list of images while you get that cup of coffee. Set the C1 Reset switch to Auto. Auto allows the program to try to reacquire Comp 1 should it have moved too far from the previous image, such as when the telescope is periodically repositioned to make sure that the field stays centered. If set to Manual, then if Comp 1 is lost, a prompt appears to tell you to reset the location of the star by doing a Shift plus click on Comp 1 in the image. You are then asked to confirm that you selected the correct star. If not, you could try again. Set the Redo switch to Yes. Each time an image is measured, the program checks for an observation with the same target, filter, and magband, and image start time within about 1.5 seconds. When set to Yes and that observation record exists, the new measurement overwrites the old. When set to No, the original record is retained and the new one is ignored. Set Auto to Yes. When set to Yes, the program automatically loads the next image in the list after measuring an image. When set to No, the program waits for you to press Enter on the keyboard to load and measure the next image. Click the Load button. Information about the selected images from the review page are loaded into the list. The images themselves are not loaded into memory, only the one being measured. Its memory is released when the image is closed. To clear the list on this page, but not the internal list of selected images, click the Pencil button under the list. Click the Load button to load the list again. Click the flashlight button to toggle showing the measuring list color legend. As measuring proceeds, the lines in the list are updated to reflect the status of trying to measure an image. A log of errors during the measuring process is automatically created when starting the run. Click the Clear Flags button to clear any color coding in the measuring list. Click the Errors button to see the list of errors after a measuring run ends. Click the Clear button to clear the internal list of errors and the error log.
Double-click on the first image in the measuring list to load and display it on the measuring page. Click the Measure button to get things going. Click the Abort button to stop measuring images. Click the Measure button to resume. You'll be prompted to confirm if you want to start with the currently highlighted image, go back to the first image, or cancel the request. Click the flashlight button below the measuring list to toggle the color coding legend. The background and text color of an item in the list changes when it is loaded and then again after the program tries to measure the image. The legend shows the meaning for each background and text color combination. Measuring images is CPU intensive. Try to avoid doing other CPU draining operations while measuring. Do not click on the list while measuring. This could reposition the list such that some images are measured again, or some are not measured at all. Once you've measured all the images, you can go to the analysis page to take a look at the data. Analysis of the data will be covered in a different tutorial. If you have images from additional nights, it may be better to measure them now and wait for lightcurve analysis until all images are measured. Then again, there are many circumstances where after measuring data for a night that you want to check the new data and do lightcurve analysis so that you can plan additional observations. You cannot simply return to the Review Images page to measure the next set of images. The program needs to clear itself first, but you don't have to close and restart the program to do this. Click the Restart button. This displays a message giving you an option to clear the existing review images or to keep them. You would do the latter for those times where you want to measure the same images again, but for a different reason. It's time to take a break. Or, if you want, reset the program and measure the images for the second night for AF Herculeum. When you're rested, view the tutorial on generic lightcurve analysis found on the MPO YouTube channel. This concludes this tutorial for doing multi-image variable star time series photometry. More tutorials are on the MPO YouTube channel by using the URL on the screen. Please subscribe so that you can be notified when new tutorials are available. If you have any questions or comments, please send them to the MPO software forum on IO Groups. Please note, you cannot attach files to messages. If necessary, you will be asked to send them offline. Thanks for watching.